So in this video I'm gonna treat the puzzle Peeping Out 2, a more advanced puzzle published on Friday, January 26th of 2024. And like the puzzle on Monday, Peeping Out 1 actually, it shows a unit square, so a square of side length 1 and area 1. Together with a blue rectangle that touches 3 of its sides, and that passes, the upper side passes through the midpoint of the upper side. And the question is, what is the minimum value of the blue area? So what's the minimum value of the rectangle area? And I will show that there is actually a minimum. Let's make visible the points, the vertices, and I can slide this vertex here, and you see that right over here it is the area, the blue area is a half, and then it goes all the way up to 1, so it's there. And if you slide it down here, the area is also larger than a half, as you can see over here. And when you get here, so this is the when these vertices are concurrent, you get also an area of a half. So it seems like the minimum is a half, but of course we need to prove that. And I will take the approach of Nathalie Guo, which is rather intuitive. You can of course calculate it exactly and take the derivative and all such, but it seems not necessary, because let's take her approach. The first thing to do is to draw a triangle again from here to here to here. This triangle covers exactly half of the blue rectangle. And let's make it another color. Let's make it red. So this triangle is half, the red triangle is half the blue area. Then compare that to another triangle from here to here to here to here, and let's make that green. So the green triangle, well, that's very easy to see that it has base half and height also half, so it has an area of a quarter always, irrespective of where this point is on the lower side. Now the argument is this: they have the same base, this line segment over here, and the argument is that the height or the altitude of the red triangle is always bigger than the altitude of the green triangle. And why is that? Because you can see that from this vertex over here that's peeping out on top, it's always on the left of, let's say, the middle. If I draw the perpendicular bisector, which is exactly the middle, then this vertex is always on the left, which means by symmetry that the lower vertex over down here is always to the right of the midpoint. So what you see is that, let's say these lines, this line and this line, they are always like this, so they are converging on the top, or in this situation they are parallel, but in this situation they are parallel, but they never go the other way. So this means that this point down here, so this apex of the red triangle is always further away from this line. Let's say if I make it red, so the baseline, so this point over here is always further away from the baseline than this point over here. And because they have these triangles have the same base, we conclude that the red triangle always has an area larger than the green, which had an area of a quarter. So the red is always bigger than a quarter, which means that the blue area always is larger or equal than 1/2. And that concludes the proof of peeping out 2.